Here you see the problem from population ecology. Some students during a study caught, marked and released 80 fishes in a pond. Later 100 fishes were caught at random. Among these, 40 were found to be marked. What is the approximate number of fishes in that pond? It was a question from 2001 APMT. To do these kind of questions, we use Peterson mark and recapture method. Peterson mark and recapture method principle is P equal to M into R plus U by R. P equal to M into R plus U by R. So, according to Peterson mark and recapture method, P equal to M into R plus U by R. In this, M equal to marked fishes, R equal to recaptured and marked fishes, U equal to unmarked fishes. M equal to marked fishes, R equal to recaptured and marked fishes, U equal to unmarked fishes. So let us apply the formula here to do this problem. M equal to, we said marked fishes. So see how many marked fishes are there in the problem. 80 are marked fishes and R. R means recaptured and marked fishes. How many recaptured and marked fishes are present here? That 40 they said. Then U, unmarked fishes. How did we calculate the unmarked fishes? You see here in the problem, later 100 fishes were caught at random. Among these, 40 were found to be marked. That means 100 minus 40, that equals to 60. So 60 are unmarked fishes by again recaptured and unmarked fishes. That means 40. So then let's do the same again. 80, 40 plus 60, 100, 80 into 100 by 40. 80 into 100 by 40 we got. Here we write 80 into 100 by 40, which means 40 1 and 40 2 2 into 100. So the answer is 200. So the answer here 200 is the answer. Let me say once again, to do this kind of problems, P equal to M into R plus U by R. In that, M marked fishes, R recaptured and marked fishes, U unmarked fishes. Let us do the problem here. P equal to M into R plus U by R. So, M. So, what is the number of marked fishes here? 80. Then R recaptured and marked are said to be 40 plus that in the second trap we got 100, but in them 40 are marked, so unmarked fishes, 100 minus 40 we get 60. So 80 into 40 plus 60 by R again, that means 40. So what do you get here? 80 into 100 by 40. So 40 1 40 2 2 into 100. So finally we get the answer here 200. So this is the answer. There is another method to do the similar kind of problem here. That very simple method here. 80 by X. X means we don't know the total population, that's why we made it as X. And that marked and recaptured are 40 out of 100. So simply what we do here, we know a basic mathematical principle that 40x equal to 80 into 100. So that means 80 into 100, it's about 8,000 we get. 8,000, x equal to 8,000 by 40. Then 4 200, so we get the answer 200. This is the simplest method here to do so. Simply what we do here, that 80 by x equal to 40 by 100. Then 40x equal to 80 into 100, x equal to 80 into 100 by 40. That means 8000 by 40. And we got finally 200. X equal to 200. Here we have another problem. An estimate of the fish population of a certain pond was found by catching 200 fish and marking and returning them to the pond. The next day, 300 fish were caught, of which 50 had been marked the previous day. Estimate the fish population of the pond. As usual, we'll go with our own principle, that P equal to M into R plus U by R. P equal to M into R plus U by R. So, let's take once again what is M here. The marked fishes are belongs to M. That means 200 are marked fishes. Recaptured and marked are about here 50 plus unmarked 300 minus 50. That means 250 by that recaptured and marked again 50. So 50 plus 250 300. 50 plus 250 300 here, and 300 into 200 into that 300 by 50 will make it, and 200 into 300, that will come about 6000. 6000 by 50. So let's cancel the 0. 5 anja and 5 12 ja. So that means here, excuse me, we have one more 0. 200 into 300 is about 60,000, and we get the answer 1200 here. 1200. P equal to M into R plus U by R we applied. In that 200 is the captured marked fishes for the first time, and next day that out of 350 are marked. So the R value is 50 and unmarked is 250. Then by 50 R again. Then 300 into 200. 300 into 200, that is about 60,000. Not 6,000 here, 60,000. So 51 ja 50 1200 ja. So that the population is about 1200 here. Let's do the same problem in our method. A simple logical method here, that 50 by 300 equal to 200 by x. So you see here how we get this particular, that 50 by 300 means 50 are marked on the second day out of 300, and 200 for the first time marked out of the total population. So then simple again, that a simple logical way, a mathematical principle, 50x equal to 200 into 300. That means 200 into 300, that's about 60,000. Then x equal to 60,000 by 50. So 51 ja and 15 1200 ja. So we get the answer again, x equal to 1200. Here we have one more problem. In a certain pond, 50 fish were caught and tagged. 50 fish were caught and tagged and returned to the pond. A few days later, 50 fish were caught again, of which 2 were found to have been tagged. If the percent of tagged fish in the second catch approximates the percent of tagged fish in the pond, what is the approximate number of fish in that pond? Similar kind of question this is. Same formula we apply here. P equal to M into R plus U by R. Similar formula again, P equal to M into R plus U by R. In that M, the marked fishes are about 50 and recaptured and marked are about 2, and U unmarked about 48. 50 minus 2, we get 48 here. So 50 into 50 by 2, that means 2500 by 2. So the fishes are about 1250. So answer is here 1250. Yes, let's do the same in the second method, that 50 by x, the first trap is 50 and the second one 2 are marked out of 50. 50 by x equal to 2 by 50 and 2x equal to 50 into 50, that means 2500. So x equal to 2500 by 2. Then we got the answer here, 1250. Let's see the another problem here. 300 fish are tagged and released into a pond. A month later, 100 fish are caught and then released back into the same pond. Of those 100 fish caught, only 15 had tags. How many fish are in the pond? Is the answer 2000 fish? Let us see. Yes, let us apply our formula. Peterson's marked and recaptured formula here. P equal to m into r plus u by r, which is m. The marked fishes are 300, and in the second trap, the 15 are tags. 15 had tags. That was given here, r, and plus u unmarked amount. The second trap are about 100 minus 15. That means 85 by 15. So here it will come 300 into 100 by 15. That means 30,000 by 15, 15 1 ja and 15 2000 ja, and we got the answer here, and we can confirm here this the answer is 2000 fish. Yes, answer is 2000 fish. Yes, doing the same in second method here, that 300 in the first trap by x equal to that 15 out of 100 are having tags here, and we apply the simple mathematical formula that 15x equal to 300 into 100, that means 30,000 we get here. 15x equal to 30,000, that means x equal to 30,000 by 15. As usual, 15 1 ja and 15 2000 ja, we get the answer 2000. So is the answer 2000 for a fish? 2000 fish are there in pond? Yeah, 2000 fish are there in pond. Here one more problem. An estimate of the frog population in a certain pond was found by catching 30 frogs, marking them and returning them to the pond. The next day, 50 frogs were caught, of which 14 had been marked on the previous day. Estimate the frog population of the pond. Yes, here we do the problem. P equal to m into r plus u by r. 30 in the first capture in catching, and 14 marked are again recaptured, and 36 the new one unmarked. So 30 into 50 by 14, and here 14 1 ja, approximately we get 107 here, 107. So our answer is the frog population in the pond is 107. So doing in another method here, 30 by x equal to 14 by 50, and 14x equal to 50 into 30, and the 14x equal to 1500 here, and x equal to 1500 by 14. Approximate we get answer 107. So the frog population of the pond is 107. Thank you.